This is problem 5 in section 8.2, and it's so long I had to cut it in half, and so this is part 1 of it, and part 2 will come up right after we do through part C. So let's start. Problem tells us that X is a random variable that represents red blood cell count, about RBCC, all right, and then we know over here. Then X has a distribution that's approximately normal. So they're telling us that X has a normal distribution. So sometimes the blood RBC is low, sometimes it's high, but mostly it's right around these mid values here. Now, for the population of healthy adult females, let's suppose, just suppose, that the mean is 4.66. All right, so we're going to assume that the mean is 4.66. And then suppose a female patient has taken 6, so N is equal to 6 lab tests over the last several months and has come out with these numbers right here. Now what we want to do is we want to get these numbers, all right? So we're going to get X bar and S. And we know how to do this on our calculator, so let's put these numbers into list 1. All right, so go to Stat, select number 1, which is Edit. And when you press Edit, you're going to get 3 lists. There's actually 6, but we can see only 3. You probably have data in here already, so you want to eliminate that, clear it out. So put your cursor right on list 1, get your cursor into list 1 with your arrow keys, then use your up arrow key and get the cursor right on L1. So L1 is highlighted, and then you're going to press Clear, which is on the right side of your keyboard, and then Enter. And all that data disappears. And now your cursor is right in the top position. So type in these numbers. I'll just read them for you. 4.9, enter. 4.2, enter. 4.5, enter. 4.1, enter. 4.4, enter. And 4.3, enter. And now down at the bottom, it should say L1, and in parentheses, it's probably saying, how many pieces of data do we have in here? Let's be sure. 1, 2, 3, 4, 5, 6. So what it should be reading down here is 7, meaning it's expecting the 7th piece to come in, which means you have 6 pieces. Now let's do some statistics on here. So go to Stat, press the Stat key, and then over to the Test key. We're going to do a hypothesis test. Now, what have we got here? Let's look to see what we have and what kind of test we're going to use. Number 1 is a z-test. That's if we know that things are normal, so we could use a t-test. Number 2, all right, this is a t-test. Now, when can we use a t-test? If we have a small sample and sigma is unknown. I think what we're going to use here, even though they're telling us that up here at the top, that X is approximately normal, we still don't actually know sigma, right? There's nothing in here that tells us what sigma is, the standard deviation, and we have a small sample. So I think that we are going to use number 2, all right? So select number 2, so press number 2 or scroll down and enter. And then it's asking us for several things. Well, first up, it asks us, are we inputting data or statistics? Well, we put our data into list 1, right? We input the individual data values. We didn't put summary statistics like we didn't put in the mean or the standard deviation. So select data, all right? So we'll select data. All right, so you select data, press enter to select that, and then scroll down with your arrow key. Now, what are we testing here? We're going to test, I'm up here, we're going to test that the mean is 4.66. Right, that's what it is that we're testing. So put in a 4.66. You put in 4.66. I'll do that here, 4.66. And then what about the data? The data is coming from list 1, so we need an L1 in there. And how do you get it? You press second and the numerical key 1, because right above the 1 is an L1. Right, so list is coming from L1. The frequency, you want a 1 here because each piece of data we're putting in only once. And now what are we going to put in here? All right, well, look down here to see what they're telling us. What they want to know is, all right, part 2. Do the given data indicate that the population RBCC is lower? All right, so they want to know, is there enough evidence to claim that it's lower than that 4.66? So lower tells us we're going to select that the mean is less than the 4.66. So put your cursor on this one right here. Select that one, press enter. Go down to calculate, right? And then lots of stuff comes up. So this is what came up for me. Now the first thing that comes up is going to tell you mu is less than 4.66. That's what we're testing over here, right? So it'll just remind you that you're running a left tail test. Then it's going to give you the t value. Now I typically call that t star because that's our computed value. And then it's going to give us the p-value. Now, this is what we're really looking for. That's going to tell us if we reject or fail to reject. But what do we have up here? Okay, this is part 1. It says, what is x bar and s? We have that. Calculator tells us x bar is 4.4 and s is 0.28. So let's put that in here. Up at the top left, for x bar, I'm going to put in 4.4, and for s, I'm going to put in 0.28. Now it tells me to round to 2 decimal places. So I guess I need a little bit more over here. Oh, well, x bar is just 4.4. So, but it wants 2 decimal places. So maybe I better put that in just so it accepts it. Now what have we got here in part 2? Do the given data indicate the population mean RBCC is lower? Well, there is some indication that it's lower, right? At least it's not greater than 466. All right, and we want to run this at 0.05. So here's the question. What's the level of significance? I'm going to guess that it's 0.05. And now state the null and alternate hypotheses. Well, the null is going to have an equal sign in it. So here's some equals. So, and we're running a less than test, a left tail test. So that's a greater than, that's a right tail. There's a left tail, that's a two-tailed test. Let's go with this one right here. All right, we'll go with this one. So let's select that one. And part B, what sampling distribution will you use? Okay, well, we're going to use not the standard number, right? We're using a t. And why did we decide the t? Well, let's see, there's 2 of them down here. Which one matches what we want to do? Since we assume that x is normal and this is unknown, sigma is unknown, since we assume x is normal and t and sigma is known. Well, sigma is not known. So we're assuming that t is normal, but sigma is unknown. So we're going to go with this one right here. Students t, because we assume x is normal. They're telling us that. But sigma is unknown. So let's go with this one here. And then what is the value of the t statistic? Well, that's what's nice about having the calculator do the test for us, is this part right here. What's the value of the t sample statistic? Right there, negative 2.25. Now we could do that by pencil. We have a converter that says this: t is equal to x bar minus mu divided by s over square root of n. So we could make that computation, and that would come up with our negative 2.25 value. Right, now part C says to estimate the p-value. Well, we've got the p-value over here. This is about 3.7%. So which one is it over here? This is 10% between 10 and 25. That's not it. This is 5% to 10%. What are we at? We're at 3%. So do we think that's going to work? Well, this starts at 5%, so that's not going to work. How about this one? This goes 1% to 5%, and we're at 3.7%. I think that's where we're going, right? 10% to 5%, and we are at 3%. So let's select this one. Now here's the rest of the problem. It says sketch the sampling distribution. Okay, so we were doing what? We were doing a left tail test. So we were doing a left tail test. I'll draw it here. Here's what I think we were doing. We had a left tail test at 0.05. So this one is not it. That's a left-tail test, but way too much area. This is a two-tail test. This is a left-tail test. Oh, actually, what is that t-value here? Look at that t-value. Now, I'm going to go back a page to get our t-value. All right, so I'm right over here in our summary. What's the t-value? Negative 2.25 with a left-tail test. So going back to our picture, what is that t-value right here? Looks like negative 2 point something and a left-tail test. Now this one over here is 2 point something, but it's a right-tail test. So I think this is the sketch that we want, so let's name that one. Now, part D says, based on our answers, what are we going to do? Are we going to reject, fail to reject? Well, let's see. We know what to do if we compare P and alpha. So what I'm going to have here is, I always draw a little picture like this. So P is 0.0371, alpha is 0.05. So 3.7% is less than 5%. And if it's less than, probably remember this by now. This is reject H naught. All right, so we're going to reject H naught. So which one of these choices down here say this? All right, at alpha equals 0.5, we reject the null hypothesis and conclude that the data are statistically significant. That's exactly what we want to do. When you reject, you're saying that there is a significant difference between the observed value and the assumed value. Now what we're doing is we're assuming, right, H naught is saying that the mean is 4.66. Our H sub A says that mu is less than 4.66, and our observed value was 4.4. So we're saying that there is a significant difference between the 4.4 and the 4.66. That's what we said. That's what we mean when we reject. There's numerical difference, but it's also statistically significant. All right, so we're going to go with this top choice right here. And now finally, interpret the conclusion. All right, so there is sufficient evidence at 0.5 to conclude that the red blood cell count for this patient is lower. That's exactly what we're doing. There is sufficient evidence. That's why we rejected. This says there's insufficient, so we're not going with that. We're going with this one right here. Right, and that takes care of this problem.